All right, geometry friends, we are on missing sides with trig. We're actually going to apply. We're not just finding ratios anymore. So, big things you need. Obviously, packet, page 17. If you don't have it, pause the video. And if you need, well, now we do need a calculator, please, because we need to do sine, cosine, tangent functions, and we do not want to use trig tables, which I'm not even going to show because they are overwhelming and upsetting, and if anybody's ever used them or seen them, you will understand. Quick Google search, trig tables, and you'll see how much you'll say, oh my God, I'm glad we have calculators. The other thing is that if you don't have a calculator, instead of just typing in calculator into Google, if you go to the daily doc, I have on the top of it, you'll see big flashing arrows. It says scientific calculator. It's from Desmos. If you click that, there is your free scientific calculator. And what you'll see right in the middle of it is sine, cosine, tangent. That's what we need for right now. Okay, so pause the video if you need to, get everything organized. Calculator, packet, or get online with Desmos. And you'll see I'll have a link right in the daily doc for you. Handle that, and off we go, my friends. Oops. Here's the first thing. Now I'm trying to settle in here with showing you where this can connect. First thing I want to do, we're going to use special rights, and again, I know we can use special rights because 45, which means it's x root 2. So we're going to connect this using trig and showing you how it's the exact same thing. I know this is 9, and then that would mean that the x root 2, that would be 9 root 2. I have all the sides. I want to find the hypotenuse. That means that it would be 9 root 2. That's exact value. Decimal form, that means I'd have to use calculator. So 9 root 2. I'm clicking it into my calculator. And that would be about, rounded near 2 decimal places would be 12.73 because it's 12.727. So what we're looking for when we try this with trig is we should see this is the same thing. Okay, but we're going to use trig. How do we do that? Well, remember trig has that TOA. First question is, well, before we were able to say, well, use this, tell me what the ratio is with sine, cosine, tangent of 45. The only step up is we have to decide which one we want to use. Okay? And we always have, in this case to start with, we'll always have a reference angle, which is here, which remember was our theta. And we know what two sides we need to use. In this case, we have this 9, and we're looking for the hypotenuse. We'll call that x. Well, from the 45, so we'll call that our theta. Here's the opposite adjacent hypotenuse. Well, you're going to have one, and you're going to need to find another. So that'll be your 2. Well, I know the 9, and I'm looking for x. That is opposite hypotenuse. So I know I'm going to use sine. Well, geez, what do I do now with all this information? Because remember before I would use, in this case, like sine theta is opposite over adjacent. But here's the cool thing is that we know what theta is now. We know the angle, okay? It's no longer opposite, or no longer just theta. It gives us the actual angle. That's what theta represents. So within this, I'm going to only have one thing missing, which is going to be this guy, okay? So I'm going to go shorthand here. I'm going to explain these two pieces. You know what? I'm actually going to pause because I'm going to shift over. This is not in your notes, but I'm going to show you because there's only 2 options when you're finding sides of things that can happen. And that's this, okay? So let's use our example here, okay? And in this case, we're going to say it's opposite hypotenuse. Now, there's only 2 things I hope you realize when I'm finding sides because the side I'm looking for is either here or here. So there's only 2 options for me to be able to solve. And again, if you're looking in your notes saying, where is this? This is not in notes. This is just to get your brain moving on what we are solving for. Okay? So it's either going to be that, or if I flip-flop it, here's what you're going to recognize. that if I do it again, sine 45, I'm either going to have the angle the side missing on the bottom or the top. Okay, that's the only two options I have for missing sides. So then you say, well, what do I do with that? Well, there's one that is pretty clear, and that to me is the one where x is here, because all we're doing is solving for x. So if you'd say, well, how do I solve for x on this one? I'd say I just times by 9, and that would be it. And then that's why we need calculators, because this is what we would put into our calculator. Now let me shift off. So give me a second, because let me get in here. Ooh, I had a blue game going. Here's what you see if you do that scientific calculator, or just if with any normal calculator, you're going to look for the two functions where on the bottom here on the left, you'll see sine, cosine, tangent. That's the big one. So if I want to set this up, well, remember I had 9 times sine 45. Well, that would mean I would go 9 times sine, and you're going to get this parentheses, whether you use a calculator or this. And I'll just type in 45. Now, the big thing I don't want to do, well, and so let me just finish this. Enter, hey, and then you're going to get this decimal, 6.636, and that'd be what we're looking for. Now, here's where a mistake can happen, is that people could put sine, let me clear, sine, and they go 45 times 9. Well, realize that it's inside the parentheses, so I'm really not doing what I need to. Okay, that's different. So I need to make sure that I close the parentheses and only have the 45. That's what's saying. It's saying I'm taking the sine of 45, or the ratio of opposite hypotenuse for a 45-degree angle, and I want to find this one equals. So you see that you have that. So just close your parentheses, only have 45. All right. Back to the action. Nope, not that action. This one, hey. Okay, so that's all I'm typing in is sine 45 times 9. And all I'm telling my calculator is that I know that I want the ratio of the opposite hypotenuse for a 45-degree angle. There's only one side length that'll make that true. And that's what you're asking your calculator to pull up, is saying that I know I want the opposite hypotenuse. And I know the hypotenuse is 9. If that angle to measure that I have is 45 degrees, what does this have to be? That's what we just found. That was this piece right here. And I know that in this case, my sine is, and we'll go to the nearest, I don't know, 10th. So if that was it, that'd be 6.4. So I'm saying in order for me to have the opposite hypotenuse, the hypotenuse being 9, again, I'm just using random numbers in this case, and I want to know what is this one to be able to make that work. Well, that's 6.4. Okay, and that's the basis. If I have the missing side on top, whatever it is, I simply just multiply the bottom and take this. And I can do that with sine, cosine, or tangent, and we'll practice that. The next one, which is the one we were actually trying to solve for, which is going to take a little bit more work because I can't simply just divide the 9 over. Okay, for this one, I either have the number on the bottom, I multiply for that. Okay, well, what if it's on the bottom? Well, I got to think a little bit algebraically, and here's how I would solve for x. I would multiply by x here. I'm going to show you the shorthand afterwards. By this, that goes away, right? Or that goes to 1. So now I'm left with simply just 9 on this side. And I say, well, now how do I solve for x? Well, I have this sine 45, so then I'd be dividing by sine 45. And then that's going to 1. So now all I'm left with here is the x, which I wanted. And that is what I'd be punching into the calculator. Now you say, well, how do I even know that? Here's a relationship you can look at, because this is what we started with. Well, what do I notice? Well, I notice that all I really did to get from here down to here is I flip-flopped sine 45 and x. Okay, and I just showed you the operations that do that. Multiply by x, divide by sine 45. So all I need to do is 9 divided by sine 45. And if you remember, let me go back, we should get 12.73, okay? This is the one we're actually solving for. So now, let me go back, and I'll do it again. 9 divided by, and my calculator here is kind of nice that it already does that for me. Sine 45, make sure you close your parentheses. Hey, look at what we just got. The exact same thing, okay? So we'll call it 12.7. We'll just go to the nearest tenth for our stuff. So you'll see that we got 12.73, woo, which is what we're looking for. Boom. And people will say, well, why didn't I just do this? This was so much easier. You are correct, which is why special rights are so nice. But you can always solve it with trig. 7.3 we'll call you. So you can see we can get the same thing. So you see where if you know your special rights, this is why it's a nice thing to have, but you don't need it. But you see how it saves you some time, where I say, oh, well, that's 9 root 2. Boom, I'm done. Okay? But you can always solve with trig when we do this. Okay? So that's the basis. We're either solving, we call this, you'll hear me say, you're going to multiply or flip-flop. This is the multiplying one where x is on the top. Here's my flip-flop, okay, because you're flip-flopping this. That's where I think in my head. So let's try a few. I'm going to do the first one here with you. So you want to use trig ratios to find the x, round to the nearest hundredth, which means the nearest 2 decimal places. Here is my reference angle. And you say, well, how the heck do I know if I'm using sine, cosine, or tangent? It's going to come down to what I'm looking for and what is missing, or what I have and what's missing and what angle I'm using. Here is my theta, and I have, if I want opposite, adjacent, hypotenuse. The two things I have, adjacent, hypotenuse, that tells me cosine is being used. And I say the cosine of what? Cosine of 44. I'm saying this ratio, when it's at 44 degrees, is a very specific thing. I don't know what the top part of the ratio is, but I know the hypotenuse has to be 25. This has to be a single value to make sure the ratio works. Well, if the x is on the bottom, I simply am just multiplying by 25. Calculator time, 25 times cosine 44, right? 25 times cosine 44. 17.98. That is the ratio. Oh, I'm going to go 17.98. That is the rate. I guess I should use some units here too, right? Go kilometers, right? Use our reference if we need to. If not, don't worry about it. Okay, it's as simple as that, but the challenge comes for you. What am I using? Is it SOHCAHTOA? You know what you're using by where the angle is, where the reference angle is, and what two pieces you have. Why don't you give it a shot? First of all, let's see if we can set up the first thing. So it should be sine, cosine, tangent of 28 equals, and then you figure out your organizing thing. See if you can do that for the next one. Pause the video. All right. So when I look at this from the reference angle, I know that this is opposite adjacent. Hypotenuse is here, and you say, well, I have it here. I don't know it, so it's unused. So I'm going to do tangent of, in this case, 28 degrees, opposite adjacent. Hey, a nice easy peasy one because I'm just multiplying by 16. Multiply by 16. So that means x, or the side length for that, I'm just going to do it on my calculator, so you should be able to reference 16 times in this case, tangent 28 would be 8.507, so 8.51. If you put it as 8.5, that's fine. Okay? Tangent's what we're using. There we go. Let's try 2 more, and we are set to go. Let's see if you can hit these 2 up. Tell me, is it, I'll give you the reference here. So, Toa. See if you can do it with those 2. Off you go. 3, 2, 1. Pause the video. All right. First one, I have, in this case, here's my reference, opposite hypotenuse. So that's sine. So sine of 55 equals 5 over x. Again, what you're saying is that sine 55 has a very specific ratio. I know one piece of that ratio. What does the other piece have to be to make it work? And in this case, because it's on the bottom, I'm flip-flopping. So really what I'm putting in my calculator is 5 divided by sine 55. I'm going to do that right now. 5 divided by sine 55, and in that parentheses just in case. I get 6.10 or 6.1. What it's telling me is that this value, my hypotenuse, which should be bigger than 5, right? The hypotenuse, here's a nice little check, is 6.1. That is 5 divided by 6.1 is the ratio for sine 55, the opposite hypotenuse of a right triangle for that to be able to work. Okay? All right. Next one. Let's see. Here we are on this one. Whoop, whoop. There's my theta. Here's adjacent. That's hypotenuse. I have so that would be cosine in this case. So cosine 57 equals 40 over x. That's a flip-flop, right? I multiply by x, divide by cosine 57. So all I'm really doing is 40 divided by cos 57, which gives me, let me do that, 40 divided by parentheses cosine 57. It's going to be big. Some people say, whoa, that's a large one. But remember, this piece here is 40. The hypotenuse has to be bigger, so don't be afraid if these numbers are getting big for 4. Okay? All right, that's the basics for us. We're just identifying based off the reference angle that we have, what two things do we need, or what two things do we have, set up your ratio, solve accordingly. You're either going to, remember, multiply or flip-flop those numbers, whatever they may be. Now, I only have a couple of sides because I want to focus because angles and sides are both in there. There's only about 6 problems. So page 18, you're going to see the very first on the skills, 8 through 10, and then I think it's on the core, 28 through 30. Just finding missing sides. Practice those 6. That is it for us, my friends. Get your practice. Let me know if you have questions. We're going to get some good practice here with angles tomorrow, and then combine everything on Wednesday and have some a fun thing. I think I'm going to get a Mario Kart game going for us. Hey, what a great time. So enjoy that. Let me know if you have questions. Try them out. Practice. We're going to get better at them. I'm going to give you a chance to do another thing with side lengths to really solidify. Get those angle practice in tomorrow. And I will see you on the next one. Have a great day. Enjoy.